So in this video, I'm going to talk about some of the logarithmic properties. Now, logarithmic properties actually behave very much like your exponential properties. And if you think about it, it makes sense because logs are related to exponents. So, first thing I want you to know is when you are adding two logs that have the same base. They have to have the same base for this to work, right? So log base a of x plus log base a of y, you can actually combine that into a single logarithm by taking your two arguments, in this case x and y, and multiplying them together. The second property is if you are subtracting two logs with the same base. So log base a of x minus log base a of y, you can condense those two together and rewrite them as a single logarithm with a division of your two arguments, so x divided by y. Now, that's all fine and dandy. And then we have the last logarithm property, which is probably the one that we actually use the most. It's how you actually end up solving equations using logarithms. And that one is if you have a log where the argument is raised to a power. So log base a of x to the y power. So this y power actually gets to fly in front and become a coefficient. All right, that is a huge property. And basically each one of these mirrors things that you've already done. So when you had x cubed times x squared and you combine the two exponents by adding them, that's the same idea here. All right. When you had x to the 7th over x to the 3rd and you subtracted those exponents, that's a similar idea to what you have there with the subtraction. And then when you had a power with another power, so something like x to the 4th raised to the 6th, well, you got to multiply 4 times 6 together and get a power of 24. That looks like a 29, so hold on a second. 4. There you go. So each one of these logarithm properties basically follows an exponential rule that you have worked with before. All right. So we're going to, in the next couple of problems, expand and condense logarithms basically using these properties. So problems 1 through 5, we want to rewrite as a single logarithm. All right. So first thing you need to notice is we have log a and we have log a. So they have to match. If they don't, this doesn't work. It would kind of be like saying that you had x to the 5th times y to the 4th. Well, those bases don't match, so you can't do anything with them. Okay? Same thing with your logarithms. The bases need to match. So they do in this case, and we are dealing with addition. So I can take these two different logarithms and multiply the two arguments together. So 2 times 10 is 20. So as a single logarithm, that would be log base a of 20. All right. Now, problem number 2, I have 3 logarithms. However, each one in this case is natural log, natural log, and natural log. I have addition, so that means I'm going to take the first 2 logarithms and rewrite those with a single argument of zt, and then I'm subtracting the natural log of b. Well, subtraction means that I can basically take the arguments and divide them. So zt over b, and there is my single logarithm. In this case, I like to write it with the parentheses so that I know where the bases are versus what the arguments are, so just keeping it all kind of together. All right, problem number 3. Now I've got a couple things going on here. We have a 2 in front of the first logarithm. We have a 6 in front of the second logarithm. So the first thing I actually want to do is fly those up as exponents. All right, so this 2 is going to become an exponent on r. This 6 is going to become an exponent on n. So log base 3 of r squared plus log base 3 of n to the 6th. Now, I do have 2 logarithms that are the same. Log base 3 is both, and I'm adding them. So to write this together, I would multiply the argument. So r squared n to the 6th. And that is the single logarithmic unit then of that original problem. All right. All right, 2 more here. Problem number 4 for condensing here. I'm going to take this 5, fly it up as an exponent, take this 4, fly it up as an exponent. So natural log of x to the 5th minus the natural log of y to the 4th. Clearly our natural logs are the same in both cases, okay? And we are subtracting them. So the natural log of x to the 5th over y to the 4th. Go ahead and put it in parentheses if you think it would help you keep track of those 2 terms together. But yeah, that's the single logarithm now from what we started with. All right, last one here. We've got a whole bunch of mess going on here. All right, so we've got 3 here. We're going to fly up that power for A. 6 flies up for B, and 3 is going to fly up for C. So let's do a quick rewrite. So log base 6 of A cubed minus log base 6 of B to the 6th minus log base 6 of C to the 3rd. All right. So basically the idea here is I have this first logarithm is positive, so that means it's going to be in the numerator, and then I'm subtracting both of these, so both of these terms go into the denominator. So as a single logarithm, this would be log base 6 of A to the 3rd over B to the 6th, C to the 3rd. And that's my single logarithm. All right, so that's what happens if you are trying to write each logarithm as a single expression. All right, now for the next set, we're going to expand as much as possible. So I want to try and write as many logarithm expressions as I can. All right, so problem number 6 here, I have this argument of 7x, which is being multiplied. So to split that up, I'm going to take log base 3 of 7 plus log base 3 of x. All right, so when my arguments are being multiplied, I can split them apart as 2 logs being added together. Problem number 7, I have some multiplication going on, but I also have a power. So the first thing I want to do is split this up on the multiplication end. So we're going to have log base 5 of 3 plus log base 5 of A to the 3rd. Now, this is not considered expanded when you have the power here, so we're going to go ahead and move that to the front. So log base 5 of 3 plus 3 log base 5 of A. That is the expanded form. All right. Number 8. So in this case, we've got arguments that are being subtracted and we have another power. All right. So let's go ahead and split the arguments for the division. So that's going to turn into subtraction. So natural log of x minus, the natural log of y squared. But I want to go ahead and deal with that power of 2. So I'm going to fly it in front as a coefficient. So minus 2 natural log of y. So that's as expanded as it can get. Now let's see. We've got problem number 9 here. We have 3 different arguments. So 3x and y are all being multiplied together. So that means each one of those gets its own logarithm. So log 3 plus log x plus log y. All right, there were no powers on anything, so I can't do anything more with that. And then problem number 10. All right, we got 4 different things going on, so I want to be very careful. So each of the two pieces in the numerator is going to need to be positive with their natural log, and then each of the two pieces in the denominator needs to be negative because, well, they're in the denominator. So we're going to have the natural log of 5 plus the natural log of s minus the natural log of 3 minus the natural log of r. So that is the expanded form for problem number 10. All right, so the next video is going to get into solving, but for right now, make sure that you are pretty comfortable and confident with these logarithm properties because we're going to be using them to solve problems. So if you're not comfortable and confident with them, send me some questions, send me some concerns.